Hello, everyone, and welcome back to another episode of what I guess now is Simon's IoT show. It used to be things on Thursdays, and it is actually Thursday today, but I'm kind of all over the schedule at the minute as I schedule this show around some other things that are going on, so I wasn't able to commit to a regular time slot. So this is episode 4 of the current project. And what we've been doing is we've been looking at some plane spotting with Redis and Node.js, and we've used the Flight Aware API, and we've used some software from Salvatore Sanfilippo, the person that came up with Redis and for a long time was the sort of core developer of it. And what that does is got nothing to do with Redis. It reads data from a software-defined radio, so I have a USB stick, and it decodes what are called ADS-B messages from aircraft. So we can basically listen to passing aircraft that broadcast these messages, get information about them, and we get some basic information like the aircraft transponder code, which uniquely identifies that aircraft, and things like a position, altitude, and obviously a time of last update and a couple of other bits and bobs. And then what I've been doing is combining that with data from the Flight Aware API, which is a paid API. So we're being careful how we use that and showing how Redis can be used to cache API calls and also queue things so that we don't hit the two limitations on my account plan, which are the number of requests I can make and the number of requests I can make in a given time. So I'm kind of rate limited a little bit. So where we were up to, and I won't go over this too much because you can sort of skip back and go find the previous episodes on YouTube down there. I've got a playlist. They're all in there. So in the previous 3 episodes, we built up a couple of components. We built something called a notifier, whose job is to pull data from the air, from the radio, and just dump it into hashes in Redis pretty much. And the way that these messages work is we don't get all of the information all of the time. So there's different types of message. So we might get a message from a plane that contains like the altitude, and then later we might get one that contains just a lat long. So we're kind of just like overwriting fields in a hash every time we receive one of these messages. So it might be additive. We're not deleting the whole hash and starting again. We're just resetting the values in those fields. And then what I had it do as well was set an expiry on those so that every time the hash gets updated, we give it another hour before it expires so that flights sort of fly past me. And this is kind of not quite line of sight, but the radio aerial's got a defined range that we can see things in. And once they come out of that range, and we haven't heard from them for like an hour, we're just going to take them out of the database so it looks after itself. So we got something pulling those into hashes, and we'll look at what that data looks like. And then we basically built an enricher component. And what that does is it goes and gets extra information about each flight from the Flight Aware API. So it will get, for example, which airport code the flight is going from and where it's going to, what type of aircraft is operating the flight, who the operator is, so the airline, and some more information like the aircraft's specific registration. And we're calling that to basically fill it out so that we've got more information about the flight. And these two components are linked by a sort of buffered queue mechanism. They use a Redis list for this. So the enricher component, as soon as it receives a call sign for a flight, which is what Flight Aware needs to go look up something, it puts a message on the list. And then the Flight Aware component pulls that off, processes it, writes more data to the hash, and we know more about the flight. And to stop this from happening too often, because we get lots and lots of messages from a plane, if we've had a call sign recently, we also put a key in Redis and you remember that. So we check if that key exists first. And if we've seen that flight recently and we've requested something for it from Flight Aware and there's like a pending request for it, we're not going to ask for it again because it's going to cost us money. And it's going to hit our Flight Aware rate limit pretty quickly. So we have those two components. Let's look at some of the data now. So I've actually frozen the data in time from the last stream because it's just easier to reason with than working with ever-changing live data. But it's also dependent on what planes are going past the location here. So We have got, let me share the screen. We have got a couple of things that we can share. So here we go. So first off, if you're interested in following along with this project, it's all in GitHub, and I'm trying to keep it up to date after every stream. I do a bit of an update, and I've been doing some work between the streams. You can find that at the link down below there. So that's in GitHub. It will be in the description for this video as well, if it isn't already. So you can find it in there. And I will just put it in the chat really quickly so that anybody following along can bring it up yourselves if you like. So here's the source code. We've got an enricher component and a receiver component. And as we were saying, the receiver component, that's job is to pull information out of dump 1090, the thing that talks to the radio. It does that as a sort of node event emitter, so it catches events, and then it puts data into Redis. We can have a quick look at how that works shortly. And then we've got the enricher component, and that's job is to, I still need to document it a little bit better, but its job is to go out and talk to FlightAware, get information about a flight from their API, store it back in the database. So that's what's going on. The other thing that we started to build in the last stream was we started to build a search index over these hashes. So we're using Redis Stack here. We can use the search capability of that to put an index over these hashes and write SQL-like queries that you wouldn't normally expect to be able to write. So we can ask for things like, give me all the planes that are within 20,000 meters of my location, or give me all the planes that are British Airways that are going past, or whatever else it is we want to do. And that's something we're going to dig into a little bit more today. So the aim of today is we want to add a third component to this, which we're going to call a notifier. And what that's going to do is, at the minute, we're gathering lots and lots of data about these flights. And we want something that kind of looks at that data periodically and says, oh, there's a flight that might be of interest to Simon or whoever else is around the house. And I should notify them of that. So its job is going to be to figure out flights that are interesting one way or another, and then notify interfaces that are interested in being notified. So that kind of sounds like a pub sub problem to me. We want to publish interesting plane events, and we want arbitrary subscribers to pick them up. So we'll look at what those subscribers might look like in a bit as well, and that'll be the topic of episode 5. We'll actually go ahead and build a subscriber that has a UI and have it update when something interesting goes past. So meantime, let's cut across to the data. So I have got my Redis Stack instance here, and it's got last week's data still in it. And let's see if we can zoom in a little bit to help so people can see. So we've got each flight here is stored in a key, and I'm using flight : and then the flight's hex ID that we get from the radio. That is, it uniquely identifies the aircraft, but it doesn't tell us very much useful about it. So, transponder 4074B2, who knows what that is? But one of the bits of data that we get from the radio eventually for these flights is a call sign that we're storing in the hash. And with that call sign, we can start to work with some industry tools like the FlightAware API to get information about what's going on. So call sign EZY57KD here is something that we can feed into the FlightAware API. And when we get that information back, it's going to tell us all of this other great stuff about the plane. So it's GEZRT. It was going from Paris Charles de Gaulle to Edinburgh. It's an Airbus A320. It's flight number 6956. And the operator here is a code that there's like a list of online. It's a IA, International Air Transport Association, I think, code for whoever owns that aircraft. U2 is a company called EasyJet. They're a low-cost airline over here in the European, I hate to say European Union, but European Union and Great Britain now as it is. So they operate in our local area. You see them quite a lot. and they have a lot of A320s and A319s, so it's quite a common flight to see go past. And then from our radio, we've got a latitude and a longitude. And if you remember from previous streams, I was also making this other position field. And that's because the search capability in Redis Stack expects lat long data to be in this format, and it expects it to be in a string that's actually long : lat, which always sounds the wrong way around to me, but apparently GIS people will tell you it either doesn't matter or that is the scientifically respected order. I don't know. I always say lat long, but it's long lat in Redis here. So we've got all of this data, and I've suspended all of the expiries. So this would have all expired because it's quite old. And the other thing we're storing is a last updated. So when was this hash last updated? We're only doing that from the radio. So whenever the radio last saw a message for this plane. And then what you'd see when the code's running as normal is the time to live up here would start ticking down from an hour to nothing. And then this flight would just disappear an hour after we last heard a message from it. So we got all of this information in here, and it's going, it was going pretty well. We were getting all of that stuff. We were able to capture loads of things, talk to FlightAware, improve the quality of the data. So this one, as you can see, hasn't had that FlightAware step put on it yet. Maybe it was pending when we stopped the system, but others will have. So if we click around a bit, here we go. Here's another one. This is a Turkish Airlines flight. TCJOE is the aircraft. It's a Airbus A330 Manchester, going to Manchester from Istanbul. So we can see we've got all of this stuff. Then what I wanted to build out of this was basically an interesting flight notification system. So you could say, well, okay, what's interesting? And that's kind of subjective. What's interesting to you might not be interesting to me, and so on. And I'm basically going to say that for me, what's interesting is something that's nearby, and it's a bigger aircraft. So there's a couple of classes of aircraft. There's like wide bodies and narrow bodies. Generally, if you go on an aircraft and it's got one aisle down the middle, you're looking at a narrow body aircraft. And if it's got two aisles, or if it's got two aisles and an upstairs, you're looking at a wide body aircraft. And that's pretty much a good way of splitting them. So we're going to say that we're interested in wide body, bigger aircraft. So we're not really interested in the sort of A320 and the 737 that comes along all the time. You wouldn't like go out of your way to look up in the sky and go, whoa, look at that. But we are interested in this bigger stuff. So like this A330 would be an example of something that we're interested in. And we could define this as any combination of these data attributes. So we could say, something that's flown by a certain airline is always interesting. Like if Singapore Airlines come this way, we're always going to be interested in that. But we're never going to be interested in, say, Ryanair, because they only have one type of aircraft and they're really common and seen them before. So what we need to do is have something that works with this data and allows us to sort of boil it down to, okay, what's an interesting aircraft? And we started playing with stuff in the last stream. We started playing with some searches. And let's just quickly look at that. So in the README for the project here, we actually had some basic searches we can do. So we created a search index, and we can ask it questions like, tell me which EasyJet A319 aircraft have we seen or have we got in the database right now, and where are they going to and from? So we tell it ft.search. I want to search the name of our index that we created, and then I want to say I want the operator IATA field to be U2. That was EasyJet. The aircraft type field to be A319, the Airbus 319, and I want to return 3 fields from the hash. I want to know where it's come from, where it's going to, the aircraft registration, and only give you the first couple of results. So what you can see is if we go ahead and steal that query and paste it into our handy Redis CLI here, that we get a couple of flights back. So we get this first one that I think is the one we were looking at. No, it wasn't. Charles de Gaulle to Glasgow. And we also get, there's one London Luton to Inverness in Scotland. So the power of this, and I do sort of try and repeat myself with this, is that Redis is essentially a key value data store by nature. So we'd stored the, you look at these keys, they're flight and then colon the hex ID. And in order to do queries like this on a key value data store, you'd have to do loads of manual secondary indexing and building things. With the search capability in Stack, that's just handled for you. So we built this index, and we're now asking it questions like this without having to do anything else with the data. And also, if we update the data, it'll update the index for us, and the index is kept in RAM, so it's really fast. So as things come in on the radio and new flights appear, we basically get queries that reflect that pretty much immediately. Equally, if things disappear off because they get deleted or they've timed out, we've not heard from them in an hour, then they'll disappear. So that's a basic search query. We want to do a different sort of query. We want to do an aggregation. So let's see what we've got down here. So here's a good sort of start point. So which aircraft pass within 20,000 meters of where I am in central Nottingham, which is a city in the middle of England. And we want them sorted by distance, closest first. This is basically like, what's the closest aircraft to me in the data set? So here we say, I want to run an aggregate query over my index. I want to consider everything in the index, so all the flights. And I have like 3 factors that I want in my aggregation. I want position, the operator code, and the flight number. And I only want things where there is a position set. So we've got that information, and where the operator code's been set. So we've got that flight aware. And what I want to do is apply a filter essentially of 20,000. So I want to get the distance first to my position, store it as dist, and then apply a filter on that for distances less than 20,000 meters. And then basically sort that by that distance. So what you'll see if we run this sort of a little bit more imposing query is we get, let's pull this back up a bit. It considered 102 things, or it's 102 things match this query. And here are the first, however many of them, 3. So the BA85 was actually the closest flight to us at this point. And American Airlines 135 was a little bit further away, and so on. So we can start to see how you would build a notifier that basically runs a query a bit like this and says, oh, okay, well, what's the closest plane? But this will not filter for interesting planes or other criteria. This is literally just like, what's the closest 3 planes to me? And this is great, and we could get more information out of these. And there's also a way of getting the document key back in this, which will be interesting if we need to get more information. So there's kind of like where we got to, was we were finding the nearest plane to us, and then we said we wanted to build a component that runs a query like this periodically and goes ahead and just presents the nearest interesting plane. And preferably also we want to do something with, we have a last updated field inside, where is it? In here, which is a millisecond timestamp. So we probably want to do something with that so that we find like the most recent closest flight, because if the flight's been talking to us for a while on the radio and then we lose contact with it, and at the point at which we lost contact, it was quite close to us, but that was an hour ago, then that flight's not going to be there if we go look out the window. So we need to account for that and just basically say, oh, give us the most recent and closest or the most recent interesting aircraft in the area around the position that we're located. So there's quite a lot to do there, but we've got the data for it. So we're going to look at where is it? For this flight. Where's it gone? There it is. We're going to look at the aircraft type field, and we want to filter that by a set of values that correspond to aircraft that we're interested in. And we're going to look at the last updated field. And from a comparison perspective, that's essentially just a number. It's a timestamp. So we could basically start with a timestamp of, say, 0 and just say, we don't have a last time we ran this query, and then subsequent times we run the query, we could probably feed in the newest timestamp that we got in the results. So give us something that's newer than the last thing that we had, which may be another message from that same aircraft, so the same response matches because it's still talking to us, or it may be that another aircraft is now closer and talking to us. So you might find that the list changes when we've got the data running live. So let me just clear this. So what we kind of want is a set of these aircraft types that are interesting. And we said we would go with, we just make a choice because you've got to decide on something. We would go with wide body aircraft. So if we go over here and have a look on Wikipedia, what we can see is IATA has and ICAO have a set of codes for these. And the ones that we're actually getting are the ICAO codes from FlightAware. So we had a A333 for Turkish Airlines. So that could either be an Airbus A330-300 or it could be an Airbus A330-300 freighter. We don't really care if it's passengers or freight. So we have a code for that, and it's A333. So that's an interesting plane. So what I've done is kind of gone through this list and looked at the ones that are likely to come here that are interesting. So like these ones really common. We're not really that interested in those. Anything that's a sort of bigger wide body plane, so A300, but not A320s, A330s, 40s, A380s, A350s. We see these go past. So we'll deem those to be interesting. So we want to filter by all of those, and then we want to do it by the last updated as well. So this leads to quite a hefty query. So I did prepare this one in advance, so there's no point sort of going through this on the stream and figuring it out. But if we go down here, we've got this very big query here. Let's see if we can make the text a little bit bigger. And this looks complicated, but really it's just repeating a load of clauses over and over again. So what we're saying here is we want to do an aggregate on our index. We want to consider all the documents in the index, so all the flights. And we want 4 things. We're interested in 4 things. This is something I learned about yesterday. So @__key gives us the Redis key of the matching document, or hash in our case, in the database. So that's useful in case we want to then pull more data out of the document that matches the most interesting plane without having to pull all of that data into this aggregation to then just throw it away afterwards for most of the results. So we'll use this as like something we can refer to later. Then we're interested in the position of the aircraft because we want to do near us. We're interested in what type it is because we want to filter by interesting ones, and we want that timestamp. And we only want to consider flights where the position field exists, the aircraft type exists, and the last updated field is greater than some timestamp of whenever we last did this, or the most recent match that we found. So that's an arbitrary timestamp I've put in there for an example for the minute. And then here comes the thing that's going to sort of crunch this down to interesting. So we've basically got a very long filter clause here. So we want the aircraft type to be any one of these ICAO codes. So A388, the A380, 35K is the bigger A350, and so on. And we've got Boeing 767 in its various sizes, 777 in its various sizes, and so on. So all of these just basically act as one sort of filter clause. So if you are used to SQL, this is like a sort of where the aircraft type is in all of these things. And then once we've got it down to just the interesting aircraft, we want to find the, again, the ones within 20,000 meters of us. That's the same as previous query. And then what I'm doing is sorting them by last updated descending, and just returning the first match. So most of this will get thrown away on the server, and then what will come back to the client will be the closest aircraft with the most recent update, or the most recent update of an aircraft within 20,000 meters of me. That is one of these large collection of aircraft types. So I can go ahead and run this query and we'll see what we get. And because we've got a frozen database here and I'm not updating it, I kind of know what we'll get, but let's run it anyway. So what we get here is we get the key back. So if we need more information about this flight, we can ask Redis about that. We'll look at that in a moment. And then we get the fields back that we put into the aggregation. So the things that we wanted to consider or filter or work with. So I've got the position of it. I've got the aircraft type. So it's a B772. It's a 777-200, like the smaller version of the 777. We've got last updated and we've got the distance from us. So these were the things that we used to determine this was the interesting flight. What we don't have in here, and we don't really want to put in this query because we'll need to keep running it over and over and over again, is stuff that a front end might be interested in. So what's the registration of the flight? How high up is it? Who operates it? And where's it going to and from? So for that, we've got this key here. So we can copy that and we can just do hgetAll, so hash get everything on that key, and you will see what we know about this flight. So this flight that we've deemed to be the most interesting, most recent thing in our radius from us is actually GYMMT. It's a 777-200 as we knew, and it looks like it was going from Heathrow to Vancouver in Canada, and it's British Airways flight 85. So what we have here is potentially information that we could have a front end go ahead and use. So in order to do that, we kind of need to solidify this query into some code and then run it periodically. And what I did, again, because it's quite a long query, so it's a little bit tedious to do live, is I kind of went ahead and started writing that extra notifier component. So let's first off clear that and go have a look at some code. So that was the README there. So I've got this extra notifier component. It's not in GitHub yet, but it will be shortly after the end of this stream, or certainly by the end of today. And what we've got in here is, like other things, it uses a .env file that we're going to put secrets in. So that's how to connect to Redis. And then it is a Node.js module, and it uses just the .env dependency to read that .env file and inject it into environment variables for us. And Node Redis, the Redis client that we need to talk to Redis. So let's have a look at some code and see how this is going to work. So some of this is kind of boilerplate that's similar to the other components. So we're just importing .env and creating a Redis client, loading up the things out of the .env file so that process.env contains things. And then we're saying, okay, let's use the Redis URL environment variable, or drop back to local Redis if we don't get anything. We'll come to what this is and why it's kind of an array in a second. And we'll come to why we've got this in a second as well. But generally, our code, it flows a bit like the other components. So we're going to create a Redis client, supply all the credentials for talking to Redis. In my case, I'm using Redis in the cloud. And you can sign up for that and try it free at, I think it's redis.com/try-free. I should have a banner for that. But you can go there and sign up for that and get a Redis stack instance. That's what I'm doing. It basically means that you've got a Redis up there in the cloud that lots of things can connect to, which is great when you're building microservices. So these things can all run in different places if we want them to. We're then basically connecting to Redis, and then I'm just going to sit in a forever loop. I'm going to run this command, and we'll look at why I'm doing it this way in a moment. Just log the response for now, and then go to sleep for 30 seconds. So this is going to kind of poll the database with this find me an interesting plane command. Now, we've got a couple of things going on here. So first off, I'm using a Redis client.send command. And what you'll notice when you work with Redis and Node.js or most other languages is most clients, including Node Redis here. So we could do .ft, I think it's .aggregate. There we go. We could run this ft.aggregate command by calling a function that is kind of like a helper for it. And this gives us like a formatted object to build up our query in. And the query that I've got is kind of fixed, and I didn't have time to basically look at this yesterday. So what I'm doing instead is using a send command, which basically is send an arbitrary command to Redis. And what that means is we have to format that command as like an array of individual strings that make up the command, because that's how the underlying Redis protocol works. And when we get the data back, we'll get an array of arrays, and Node Redis won't pass it out into objects for us. And that's okay to get started with. And if we like this approach, and once the command's settled down, I will take a look at tidying it up into a format that looks more like this. One great thing with Node Redis is there's this examples folder here on GitHub, and inside here, there's examples for how to do all sorts of things. And in here, we've got an example for how to actually run the ft.aggregate command. So here we go. ft.aggregate, JSON. Your index, the documents that you want to consider. So we've got star as well. And then you build like an aggregation pipeline object up. So I need to spend some time with this and turn what we're going to do today into something that looks like this. So we get a slightly, as you'll see, we get a slightly better parsed out response here. We're going to be dealing with an array of arrays today, but that's okay for making progress. And basically we can always finesse it into this format later. So I'm not going to worry about that. So that is the ft.aggregate in Node Redis. If we go back here, I said we've had to create this sort of array of command parts. And this is because if you've seen some of my early streams on things on Thursdays, we looked at how the Redis protocol works, and we created a Redis compatible Bloom filter that understands it. And the way it works is it sort of breaks things down into strings, and then the client is, in this case, doing things like telling Redis how many of those strings to expect and separating them for us and so on. So we have to give the client something to work with. So I've broken up the query into this array, and this looks like kind of a hard thing to do. And for reals, we should use that aggregate object in Node Redis. It's much higher level. But for just playing around with something, this works pretty well. So how did I know to break, for example, ft.aggregate is one string, but if we look here, like the filter keyword is one string, but the value of the filter is one string itself. So when we get to like this really long aircraft type filter, all of that needs to be one string. So how did I know that? What I did was kind of cheated. So if I go back to the Redis CLI here, and I can run that command here and get the response out. And that's okay, but we don't really see what's going on under the hood. And what we need in this case is something that's closer to the wire protocol for Redis to just feed into that array. So if I turn on the profiler here, do not do this in a production database because it does slow the performance down. But this is just my non-production personal database, so it's fine. So if I start the profiler here, it's going to do what's called the Redis monitor command, and it's going to report back all commands that are sent into this Redis server. And it's going to show them in the format that they were received. So the CLI over here, if I run this big query, you will see that this is the format it was received in, and it's kind of broken it down into the strings we need. So I just basically took that, pasted it into Node, and put commas between the strings. So we've got an array. So that's how we're going to get up and running really quickly with a relatively complicated command that we don't want to mess around with building out nicely because we're still working on it. We don't know if it's the final form. So that's what we've got here. And then when we run that, we just send that into send command, and it just throws it at Redis in the right format, and we get a pretty raw response back. So what I'm going to do is run that and see what happens. So let's do npm start, and we'll stop it after one go. So it's run a few times. What is going on there? Oh, yeah. I'm not awaiting the sleep. That's a bit of a error there, isn't it? If we do that and actually await the sleep, it should run once and then sit around and then run again, and we'll get the same result. Okay, so what we get back is less polished than if we'd used the ft.aggregate function in Node Redis, because it's not going to parse the response for us. This is like arbitrary Redis command, so we get arbitrary Redis response. And what we get back looks a bit like the format over here in the CLI. So like number one over here was 102. So the first thing in the array is the number of things that matched. And then number two is like a Redis array response. And you can see it pretty much matches up what came from the CLI. So we got the key and the value of the key, the position and the value of that. Basically name value pairs. So we can see that we've got this same aircraft back from our code now. So what I wanted to do was also do something with the last updated time. So here I've got the last updated set to 0. And what I wanted to do was take the value of this and feed it back into the query the next time. So we look for something that's newer the next time we run. Because we don't want to keep notifying front ends of like, oh, here's the same flight with no different information whatsoever. We only want the front ends to get notified when there's something new to show them. So what I want to do is modify this query slightly. So we're going to start at position 0. I need to get out this last updated field. And again, we're going to do this slightly quick and dirty because we'll tidy it up later when we've got a proper response and a proper response object. But what I want to do is let's do new last updated equals. Well, actually, first what we want to do is let's not do that. Let's demonstrate what would happen if we ran with this timestamp, because we need to consider that case as well. So we say, give me something newer than that flight. We're not going to have that because it's a static data set. The radio is not running at the minute. So when we do that, all we get back is an array with a single item in it. And it's like, oh, I considered 102 documents and there's no matches. So we do need to like take care of that a little bit. And let's pull that back to 0. So what we need to do is basically do, let's log the response still, and then if response dot length is 2, and we got something back, so we need to update the timestamp the next time. And what we then need to do is grab that timestamp and put it in the query for next time. So let's do const updated timestamp is going to be response 1 brackets. Again, you shouldn't really rely on array ordering, but this is kind of demo code, and we're going to replace it with an object later. So 0, 1, 2, 3, 4, 5, 6, 7 sounds decent. So, and then let's see if this works. Console log that out, and let's go run that and see what happens. Either work or it'll fall over. There we go. So we got the timestamp out, right? So that's okay. And then what we need to do in this case then is update the query. So the query is aggregate command. It's an array, so we need to update a position in the array, and let's set it to basically last updated is greater than, we use template string, updated timestamp. So hopefully that will, once we figure out which position in the aggregate command we need to update, that will then basically the next time ask for things that are newer than what we saw last time. And it's a little bit brittle, but it gets us moving forward. So here we've got this command, so we need to find out what position that is. So it's 0 index, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll make that 10. So let's try that. The aggregate command 10 equals that. And then let's see, just output something here. No new matches, and we'll go to sleep. So yeah, if we get 2 things back, we'll do that. And then obviously we also kind of need to also notify anything that's basically interested in this to see if there's any new data, or rather tell it there's new data and you should display it. So let us go back to our command line here, clear that, and hopefully what we should see is it starts at timestamp 0, and then it picks up the timestamp from the first most interesting plane, and the second time around it will say there's nothing more interesting because we're not running the receiver, we're not changing the data set in real time. So there's the first one, and then hopefully the second one, in how many seconds I set this to, should have set this to a shorter time really. It will hopefully come back and say, you know what, there's nothing of interest. Seems like an awful long time when you have to talk through some of these time delays. How long did you set it to? 30 seconds. Oh, there we go. Right. So it's done it. So no new matches. So it fed this timestamp in the second time round, and there was nothing new. One optimization we could do here would be, well, what if this notifier component is turned off or falls over or something? We could persist this timestamp into Redis, and like instead of starting the query at 0 here, we could start it at whatever, load it up out of Redis and start it there. That's a technique you'll see me use a lot when we're walking through a Redis stream with like X range, and we want to remember how far through we got through it. But I'm not going to actually worry about that, because when we're running this system, the flights will all expire an hour after we receive the last message. So they just won't be in the index anymore. So we could do it, but we're not going to need to do it. As you can see, we got no new matches here. And what we want to do now is a couple of things. We want to get some data from this front end. Well, here we've got kind of a design choice, right? So we could, how do we notify interested front ends? What do we want to do? We could make an assumption about the front end that it itself is able to connect to this Redis instance and pull data. And that is going to need to be the case, because it's going to be if we're using PubSub, it's going to be a PubSub subscriber. So when we publish something out to the front end, The question is, what do we actually publish? So we could publish just this here and say, hey, subscribers, flight 405 BFD, so this key in Redis has deemed to be interesting. So you should go get whatever information you need to show the front end user from that key by using the hget command with either hget all to get all of it or hget just the fields you need. And then the client would basically just listen and be told, hey, 405 BFD is of interest. You should go get that information. And it would have to do like another round trip to Redis to go get it. And that's potentially okay because it means that each client incurs a network penalty, but can be pulling just the data that it wants. Or the other way around, we could flip it on its head. So we could say what we want to publish is not just this key information. We'll send that down anyway because clients might choose to get more information, but we'll send them down a selection of things that we think all clients should show. And if they want some more than that, then they'll have to go get it themselves. So I think what we should do is probably get some information out of Redis for this flight here on the server in the notifier component and publish that. So publish like a JSON object or something so that subscribers to that can either just get everything they want out of the JSON object. They don't need to call Redis again, or they've got the information that if they choose to want to get more out of Redis, they can go ahead and make that second call to Redis and do so. So I think I'm going to go with that approach for now. So what we need to do here is first off, get more information about the interesting flight. So let's get rid of this console log. We don't need that. So what we need to do here is await Redis client dots. Let's just get all of it. So we could use hget and provide a list of fields that we're interested in. Let's use hget all because we're operating on a server here. We're not some little IoT front end device, and these records aren't, to be honest, that big. They don't have too many fields in them that getting all of them is going to cause Redis or this server process problem. So we need to do that. That works off of a key, and we'll figure that out in a minute. And we'll do flight details equals that, and then we'll dump that out for the minute so we can make sure it's working. So we need the key in here. So the key, as we can see, is this thing here. So in that second array element that we got back from the send command, whoops, I don't want to copy and paste that. It's item 1, so 0 indexed arrays. So let's just do this. And let's get the key. And again, a little bit brittle because we're kind of hard coding array positions, and we'll clean this up into an object once I've figured the aggregate command out off stream, and then I'll review that in the next stream. So we can do response 1 and then it's position 1. And hopefully that will then give us, when it pulls that flight, there we go. But it gives us all of this information about the flight, and then we can choose what we want to pass down to our front ends. So what we're going to put in our pub/sub message. So let us then notify interested front ends. So Redis has a pub/sub mechanism. So you have publishers and subscribers. It's ephemeral, which basically means it doesn't appear in the key space. And that's okay for this. We don't want to use a Redis stream where we've got a record of every flight that was deemed to be interested at a given time. That might be a fun thing to have, though, because then we could build something that goes over like a period of time and says, oh, okay, in the last week, these were all interesting flights. But we're kind of more interested in real time here. So if a front end is not listening for these things at the time, the fact that it's not going to get them because pub/sub is ephemeral doesn't matter in this use case. We're just, okay, if you weren't turned on, then who cares? Because by the time I turn the front end on next week, if it suddenly goes, oh, there's something else in the interesting flights queue, and that was from last week, it's no use to me. I'm not going to like look up and expect to be able to see it or be able to go to FlightAware and go, "Ooh, tell me more." So PubSub's okay in this case. So we want to build up and PubSub takes a string. So we're going to build up a JSON object and then stringify it. So let's build up a JSON object there. And then once we've got that, we want to do, oops. We don't really need to await it either because we just get on with doing other stuff. We don't really care about the response. Dot publish, and then we need a channel and a message. So we'll say that our channel is going to be called Interesting Flights, and that's going to be something that the subscribers will need to know, and that's kind of like going to be their contract with this whole system. So the front ends will only need to know about interesting flights to get the information we're going to pass them. So all they'll do is they'll subscribe to a channel called Interesting Flights that doesn't appear in the key space in Redis because that's how PubSub works. And they don't need to know anything more about Redis if they're going to use just the information in our payload. If they want to get more information about the flight than we choose to put in the payload, then sure, they'll have to go make a HGET call and know about that. But that's okay. And then we'll do JSON.stringify payload. And we don't need to await that because we don't want to do anything with the response. It either happens or it doesn't. So what do we want in here? We want something like, we want a combination of this information, the stuff that we got back from HGetAll, and this information. Well, yeah, we just want the key really. The rest of this was in the HGetAll. So, okay. So let's basically just do something like, be really lazy and maybe just send all of that. So let's do a field called Redis key, and we'll make that whatever the key was, response 1.1 again. And let's make this a little bit nicer. Const like key. If we're going to use like hard-coded array positions for now, we might as well at least not repeat ourselves. So like key goes there, and let's just call it Redis key as well because then it's and yeah, let's see if that works. So we're basically just going to make a new object with these things in and then just stringify it and publish it. So in order to do this, we are going to need some subscribers or a subscriber to see, to be around to listen for it. If we just publish something, it goes into the void, nothing will happen. So let's try running the code now and make sure it doesn't crash. And that's probably what's happened is something went out and it's not, nothing's been notified of it because nothing was subscribed. So let's see, I think I can do this in Insight. So let's do subscribe interesting flights. I think we called it just interesting flights with no punctuation. Yeah. Subscribe. Okay. So that's not supported because of the way it works with the connection. So what I'm going to need to do is quickly connect the Redis CLI off screen to this cloud database and have a second connection that you can use. So we'll clear that. And let's just really quickly start a new window. Bring it off screen here. And I'll just quickly connect this. And then what I need to do is, so what I'm doing is starting up Redis CLI with a host and a port. option that match those values for my Redis Cloud instance. And then using the auth command to authenticate with my password. And this is stuff that we keep in the secrets file. Okay, so bring this back. So we're now connected with a Redis CLI to this, and I can do subscribe interesting flights. And what you see is it's waiting for messages now. So this is basically representing what our front ends that we'll build in the next stream will need to do. So it's subscribing to the interesting flights channel. And then if I go over here and move this out of the way and rerun this component, what we should see is it should find that first interesting flight, it should publish it, and we could have many of these subscribers, which is what I want to do. I want to have like a few front ends, so you can imagine they're all around the house. And then when a new interesting flight happens, all heck breaks loose and they all update. So when we do this, off it goes there, and it figured out that this was the interesting flight over here, and it published it. And here we go, we got a message on our interesting flights subscription. And what we got is the stringified JSON for that flight. So we got the Redis key field. So if I need to go get hgetall and get the rest of this, then I can do that. But we also just put all the data in there anyway, so we probably don't need to do that. But, you know, imagine I had like my subscribers were primarily on like a really expensive, slow network. I want to keep the data size down to just the fields that they wanted, and we could tweak this. And then if I had other subscribers that were on a higher bandwidth network, we could send them the same data and they could use this key to choose to come back to Redis and get the rest of it. So that's kind of where I wanted to be today. So we've got this notifier component that we've sort of written today. And it's pretty simple. It runs, okay, what's quite an arbitrarily complex query that I will clean up so we can use Node Redis's nicer interface rather than just the arbitrary command interface. And once we get that information back, we're then using hgetall, so Redis hashes, to get more about that than our query returned. And then we're using Redis pubsub to just dump everything on there. So what I'll do in between streams is clean this up a little bit, commit it to GitHub and push it. And then next stream, which I'll announce when that's going to be once I've got a time slot for it, we are going to look at some front ends. So let us take a look at the front end, and that was our Slack channel. We have a Slack channel at work for hobby electronics, which is fun. But we also have, if you're out there in the public world, we have a Internet of Things channel here on the Redis Discord. So you can join us on there, and I'll throw the URL for that up shortly. But where I was going was I wanted to show this, which is we've got some potential front ends that we could be using. So I've shown one of these a couple of times before. It's an e-ink display here, and it's got a Raspberry Pi Pico W on the back. So we've got a microcontroller there that has everything we need to get online, run a really basic MicroPython Redis client, and we'll be able to receive that information and update, you know, a relatively slow moving e-ink screen. But this is great. It's low energy. It's super clear. As you can see from this weather example it's running, we could maybe get some graphics on there that maybe corresponds to a 4-engine plane or 2-engine plane or whatever. So that's one sort of front end we can use. Another sort of front end is I've actually been lucky enough to receive a couple of these LED displays. So these also have a Raspberry Pi Pico on the back, Pico W. So again, you can connect these to the network. You can run MicroPython on them, and they can talk to Redis and display results. So we could perhaps show them on this sort of thing. I've got, let me just make the camera a bit bigger here. I've got a couple of these. So I've got this one that you see here, the square one, again, the microcontroller is on the back, so we can program to that. And then the same thing, and again, this might be more useful for this sort of information, is we've got an LED display in this format, exactly the same principle, microcontroller on the back, that can run MicroPython. Then also behind me, I keep saying it and we don't keep using it, we've got this electromechanical bus sign that allows us to control each of these as a pixel, so we can have a nice sort of clacky update as it updates, and these things that will go and show some information from there. And the great thing with what we've built is all of these can be subscribers. Redis will do a publish from that component we've just written, and it will fan that out to all of the subscribers, and they can do what they want with that information. So, some might choose to make a noise, some might choose to display some things from the data, and some might choose to display others. And we can do that according to what the sort of sweet spot for information display on each front end is. So I am hoping to take a bit of time and put together a sort of front end mega stream, if you like, where we look at all of these things, and then never do live demos, but we might be able to pull together running the notifier and everything in real time, and basically having a real-time flight go through the entire system. So be detected by the radio, be enhanced by flight-aware data, picked up by the notifier as interesting, and notified to the front ends. We can kind of fiddle this a little bit. So at the minute, we'd be dependent on a wide-body aircraft going past. We could just change it and say, like, an A320 is interesting, and then it's pretty much guaranteed that if I sit here and talk for an hour, an A320 or a 737 will pass by. We can do that. When will that be? Not sure yet, but you can check out our schedule. And if you go to developer.redis.com/Redis Live, you will see when we are next up. Right now, it's people you can expect to see regularly on stream are myself, Justin Castilla, and Savannah Norum. Savannah's talking about Python. Justin's, I think, maybe talking about something IoT related that he's going to do a conference talk on, but he's also been doing a project with bird data and Redis JSON. So we've got a huge number of bird sightings. And then I'm here with IoT, which is going to be plane spotting for at least one more episode where we look at the front ends. If you want to catch up with us in the meantime, you can, as I showed before, go onto Discord. That's discord.gg/Redis. We talk about all sorts of things, including IoT. So here yesterday, I was talking to somebody in the community who was interested in something I built previously on stream. And we were looking at whether or not MicroPython properly supports like a bonjour host name for the PyPeak-OW yet. So if you connect it to a network and you give it a host name, it could be like mybussign.local for the one behind there, or or it could be like cosmic.local for this thing here. Rather than an IP address that you kind of have to guess or rely on having a display that can show that. So we were discussing that and sort of going back and forth on what's in the MicroPython nightly build. And I love chatting about this stuff. So come down here if you want to talk to us about that. But also you can come talk to us about anything Redis, the university courses, your stuff you're doing yourself, problems you've got with understanding the Redis clients, or if you're looking for general help with anything really. We have all of that. We also have, I can never find this. There we go. We also have a self-promotion channel. So if you've written something that involves Redis, or you've written a blog article, or you've got something to say, then go in there and we'd love to share it. There's like nearly 10,000 people in this community now. So you're reaching quite a good audience. So yeah, before I go, last couple of things. What I wanted to remind everybody of was that this is now part 4 of what's probably going to be a 5-part series. Front ends might take 2 streams. I don't know. It depends on how ambitious we get. But you can find all of the previous ones here on YouTube. You can also follow us on Twitch, and stuff lives on Twitch for a couple of weeks, but it's basically on YouTube pretty much permanently. I have a playlist on there. You can go find me. All my stuff's in there. And that's true of the other developer advocates that also live stream. So Justin's got one, Savannah's got one. Guy's been off doing other work at the minute, but he's got one. You can find us all in there. Steve Lorello as well, if you're interested in .NET content. Then other things, we run courses. So we have courses. You can sign up at university.redis.com. I put live yesterday, sign up for a new course, which is going to be about probabilistic data structures. I'm kind of excited for this because I get to write it, and it will be covering all the probabilistic data structures in Redis stack. And it's something we've looked at on this stream and Savannah's looked at on streams before, and they're fun to talk about because the basic idea is there's an element of approximation and uncertainty. So looking into why that's a good idea is kind of fun. That course will launch later in the year, but we're taking signups now. So if you want to sign up, we'll email you and we won't spam you when we're ready to start, and then you can come do the course. If you're interested in IoT stuff, there's a course on Redis streams that I've also been updating recently. So even if you've taken it before, there's some new material in there covering Redis 6.2 and Redis 7 enhancements to streams. So we have all of those. But yeah, that's about it for now. So I will see you next time, whenever that happens to be. If you want to keep an eye on when that is, go on YouTube. You can be notified through their normal mechanism. Same with Twitch, or check out the developer schedule page. I'll put it on there. And yeah, I'll just do that little bit of source code tidy up in the notifier component, push it all to GitHub, and hopefully that'll be there by the end of the day, if not by the end of tomorrow, which is the end of my week here in the UK. So have a great rest of the day, whatever time of day it is for you. It's now like 3:15 for me in the afternoon, so I might go get some fresh air. And yeah, we'll see you next time. Thanks all. Bye.